Analyzing social streams is important to many applications. However, the Twitter stream are too many, too diverse, and too dynamics to explore. It is even more difficult for end users with limited computing resources to process social streams data in real time. We present StreamExplorer to facilitate visual analysis, tracking, and comparison of a real-time social stream at 3 levels. Our user system consists of 4 parts. A search bar located at the top right of the user interface in which user can input the keywords about the event that he wants to follow and analyze. The timeline visualization contains a trend visualization and a tree visualization, which provides an immediate overview of all sub-events. In the bottom of the main user interface is the map visualization for further analysis at a mesoscopic level. In the left is the control panel. User can choose the time granularity or drag various interactive lenses, such as word lens and bar lens, at here. User can choose a proper level of time granularity. Then inputs the keyword of the event and click the button to start tracking. User can expand the visual tree of aging sub-events. When switching to geomap mode, user can click a sub-event to see the geospatial distribution of the tweets within it. When switching to topic map mode, user can click a sub-event to generate a topic map. The user can further drag various interactive lenses, such as word lens and bar lens, from the lens panel, and drop the lenses to any area on the map visualization to inspect the area from various perspectives. If user is not satisfied with the clustered result, he can refine the topic map using a brush tool to select the unsatisfied region. A well-trained topic map can also be used as a classifier that can track fast topical changes in real time. When hovering on one topic in a map, the same topic in both maps will be highlighted. Case 1. We first set the time granularity to minutes so that the system will track the Twitter stream in every minute. Then we input the keyword FIFA to begin tracking. The system will automatically track and extract the tweets related to FIFA from Twitter stream. The incoming tweets will be displayed using a line chart whose x-axis encodes time span and y-axis encodes number of tweets. If a icon passes out of the line chart, it will be collected by a sub-event tree who is organized according to time. When there are too many nodes in the tree will automatically collapse some nodes. We use multifunctional lenses to explore the topic map of sub-event happening at 1711. Through a list lens, we discover that some user post a tweet said that 0-1 German leads the game. Through a word cloud lens, we find out that in a topic the keywords are Muller, Germany, revealing that Muller scored the first goal. There are some topic clusters distributed in the map, such as Brazil and goal. We expand an aggregated node and generate another topic map of sub-event at 1725. In this topic map, we find out many dirty words. After further exploration, we found that the topic clusters in node 25 mostly reflect the disappointment of the fans of the Brazil team. Case 2. From the DICOM nodes of the visual tree, we found that most of the nodes were occupied by red cells, indicating that a negative sentiment dominated the Ebola outbreak event during the whole year. Some cyan cells were also found out to suddenly emerge in July and kept increasing until December, revealing that some important verified Twitter users posted tweets during these periods. Furthermore, the yellow cells of September and October are much more intensive. The Twitter users who paid attention to Ebola outbreak have more followers and higher influence in September and October than in July. Then we interacted with the tree by expanding the regular nodes of July, September, and October. From the leaf nodes of July, we saw that it was July 25th when the cyan cells emerged. We switched to geomap and create the geographic maps for sub-event on July 25th. From the geographic map we discover that most tweets of the sub-event came from Nigeria. We then subsequently created a series of geographic maps for sub-events to track geospatial changes over time. The sequence of the geographic maps reveal that most tweets came from the United States on the other dates. These geospatial changes were highly consistent with the global Ebola outbreak over time. Our system allows a user to interactively refine a topic map, For instance, we merged the two separate clusters, which are both denoted by patient in the top left corner in the topic map of October 1st by intuitively dragging the left to the right cluster area. In the refined result, the merged cluster of patient appears larger, and the original left cluster is replaced by a new topic cluster denoted by hospital. Furthermore, the refined topic map was used as a classifier to create two topic maps in real time for the subsequent sub-events on October 8th and October 15th. The result is depicted, which keeps similar topics consistent and stable on the map. Thus, the generated maps significantly eased the difficulty of visual comparison and tracking of the topic changes among the maps. The topic map of sub-event on October 8th shows topic clusters denoted by Duncan, Dallas, and died, which indicate that the first Ebola patient, Thomas Duncan, diagnosed in the United States, died of Ebola in Dallas on October 8th. The topic clusters denoted by Dallas and Texas become larger again in the topic map of sub-event on October 15th. Using interactive word and list lenses, we found that these expanded topic clusters were mainly caused by the breaking news that a nurse who came into contact with Thomas Duncan was diagnosed with Ebola in Dallas, Texas. Case 3. In the visual tree that most of the nodes before 5 a.m. have shorter concentric rings, which indicates that the sub-events within these nodes concentrated on a small number of topics. However, the concentric rings of the nodes after 5 a.m. are longer, which implies that the sub-events within these nodes have more diverse topics. We further examine the topic distributions. We find that keywords such as Newcastle and Remain are most salient on the topic map of sub-event at 23. By examining the detailed tweets, we found the vote result of Newcastle is 51% Remain and 49% Leave. The votes for Remain and Leave are rather close. However, as time went on, keywords such as Brexit and Vote Leave started to emerge on the topics map of node 2450. After examining related tweets, we find that more and more cities' vote counting have been completed, and the results prove to be Leave. The concentric ring of node 250 is short, which indicates the discussion highly concentrate on a small number of topics. From the corresponding topic map, we found interesting topics of Farage and Brexit. Through the interactive word and list lenses, we found the topic of Farage is mainly due to the declaration by Nigel Farage, the leader of the UK Independence Party. Furthermore, we find the node at 5 o'clock is large, and green cells start to appear in the bottom right of the scene. This pattern indicates that the sentiment appeared to be positive. Through examination with topics maps, we seldom see keyword of Remain. It seems that the voting result of Brexit have almost been settled. We wondered why the concentric rings of the nodes after 5 a.m. became longer. Thus, we select the node of 1650 and 1850 to unfold the hidden patterns. From the two topic maps, a keyword of Not My Vote emerged and started to become popular. An examination of the tweets shows that users not only tweet about the results of Brexit, but also started to complain about the result of Brexit and called for a re-vote.